Okay, so we are live. Is my screen visible?
Yeah, yeah.
Okay. So in today's late code question, we have been given minimum time visiting all points. Okay. Wherein we have been given points on a graph, and we need to calculate the distance required, minimum distance required to travel between those points from starting point till the ending points. So let me explain to you. For example, there's a point x comma y in a graph. There are total 8 ways how we can move. Either we can move forward diagonally to left side, right side, to bottom diagonal. So basically, if we move in any direction, it will just take 1 second to move. So if we take our first example, here we have been given 3 points, 1 comma 1, 3 comma 4, and minus 1 comma 0, and we need to start from first point, which is 1 comma 1. We need to reach 3 comma 4, and after that we need to reach minus 1 comma 0. So how we can go from 1 comma 1 to minus 1 comma 0 is, first of all, we can just think about visually how many seconds it's going to take. First of all, from 1 comma 1 we will move to 2 comma 2, and then till 3 comma 3, and then from 3 comma 3 we're going to move to 3 comma 4, which is taking 1 plus 1 plus 1 equal to 3 seconds. And if we have to go from 3 comma 4 to minus 1 comma 0, first of all we'll go from 3 comma 4 to 2 comma 3, then we'll go to 1 comma 2, then 0 comma 1, and then minus 1 comma 0, which is taking 1 2 3 4 seconds. And after that we can just add all the time, which is giving us 7 seconds as our answer. So what's the formula that we can derive from here is, we can calculate maximum of absolute of x1 minus x2, comma absolute y1 minus y2. We can calculate maximum of either of them, which will give us our answer. As we can also see in the second example, where we have to move from 3 comma 2 to minus 2 comma 2 comma 2, which is visually taking 5 seconds to move. And if we think about our formula, which is maximum of absolute of x1 minus x2, comma absolute of y1 minus y2, which is giving us 3 minus 1 minus 2, which is 5, comma absolute of 2 comma 2 2 minus 2, which is 0, maximum of 5 comma 0, which is giving us our answer as 5 seconds. So let's write its code. So we can start from the 0, from the first point, and go till the last point, minus 1. So we're going to do absolute of points x1 minus x2, which is, and at that we can return our answer. So yeah, so test case.
Yeah. So guys, the question that we have been asked today in today's GFG POTD is that there are two binary tree search tree that we have been given here. As you can see, here is the BST1 and the second one is BST2, and there is a value that they have given to us, and as you can see here, the value that they have given to us is 16. So we just have to find the combinations in this binary search tree such that I am going to pick one element from binary tree 1, the second element from binary tree 2, and the sum of these two elements should be equal to 16. And if the number of combinations like combination, 610 is another combination, and 88 is another combination. And thus, as there are only three combinations available, one is this, second is this, and third is this, the answer here is 3. The same goes for our second binary search tree forming. Now, as you know that as far as you guys are actually solving this problem, so I'm just assuming this thing that you know combination in an array. So how we actually do in an array is that there is a list of element that we have been given in this array. And what we do is we will apply the nested loop in this array. So first loop will start from this, the second one will start from this, and it will traverse through all these elements. So it will make a combination like this, like 1 2 1 3 1 4 1 5 3 2 4 2 5, and so on and so forth. And after finding these combinations, we will just do the addition and find their sum. As in this case, it is 3. So if the value that we have been given should be equal to such value, we can simply return the answer. Okay, this is while solving this code. So what we are going to do is we are going to create an in order traversal for each tree. So we are going to take two vector. First one will be vector 1. For binary search tree 2, it will be vector 2. So here its in order traversal will look something like this: 2, then 3, then 4, then 5, then 6, then 7, and that 8. The same goes for the second tree. Its binary traversal will something look like 3, then 6, then 8, then 10, then 11, then 15. And then the combination would be like 2, 3. That is their sum equals to the one that we have been asking. If that is the case, we are simply going to increment the value of count. That will be our answer. Now if we apply this approach, it is going to nested loop. Yes guys, nested loop. Nested loop. And as you know, the time complexity of nested loop is O of n square. So when we want to traverse through this approach and when we are actually going to submit it out this code, we are going to get what? TLE error. That is what we are going to get. Time complexity error. So what is the alternative approach to solve this problem? Because that is the only way we are going to do this thing. Either we can traverse from this binary tree to each element, either we can apply our this approach as we are actually discussing here. The time complexity for the given approach, what we are going to do is we are going to use an unordered set, and we are going to store the elements in this set of each of any of the given array. So let's just say after in order traversal I get this array and I get this array. So what am I going to do now is I am going to store the elements of v2 in our set, unordered set. So it would look something like this. So it will be 3, then 6, then 8, then 10, then 11, then 15, and then 18. And as it is unordered set, it will remain something like this. Okay. Then the next vector, which is this one, it will remain as it is. So v2 will remain as it is. So it will be 2, 3, 4, 5, 6, 7, and 8. Now what we are going to do, I am going to apply a for loop over v1. Okay, so let's just say number to be 16, that after adding these two elements, after adding one element of this one and one element of this one, the answer should be 16. So what we are now finding here is we are actually finding function, and I'm simply going to find that whether 14 is available in this set or not. If it is, then simply increment the value of count. If it is not, then we are going to move forward. So this logic will be applied to each case. So let's just say now after doing 2, we are now going to come to 3. Okay, so at 3, the remaining will be 16 minus 3, it will be 13. Yeah, so then I'm going to find that whether 13 is available in this set. As it is not, so I'm going to just move forward. So for 4, 2, 16 minus 12, I'm going to get 12. So either 12 is available, that is, as it is not, so we are simply going to move forward. Then for 5, 16 minus 5 will be 11. So as you can see, 11 is available in the set. So I am simply going to increment the value of count. So here in this case it is 0. It is 0. It will here become 1. Then for 6, as you can see, the remaining will become 10. And now we are going to find that it is available. So we are simply going to increment the value of count and it will become 2. Then after 6 we are now going to reach at 7. The remaining will be 9. So is 9 available? So as you can see, after 8 directly there is 10. There is no 9 in this unordered set. So 2 will remain 2 and we are simply going to move forward. After that we are going to reach our last element 8, and we can see that after subtracting 16 from it we are going to get remaining element as 8, and 8 is available in the unordered set. So we are simply going to increment the value of count, and here our final answer would be 3. As you can see in this case too, this is our question that they have asked us. These are the sets that we have, these are the binary search tree that we have considered. This is the output they have given, and the answer we are getting here is 3. This will be the approach that we are going to use in order to solve this problem. Now when it comes to the time complexity for this problem, it will be O of n. Complexity of find function is O of log n. So even when I'm going to do the multiplication of O of log n, it will ultimately going to be like n log n, which is smaller than the time complexity of n square. So as a result, this code of our will get submitted because it is taking the less time to run. So now, as I already described with you, or how we are actually going to solve this problem, first of all the binary tree search tree will be given to us. We are going to create in order traversal for this tree. After creating the in-order traversal, there will be one vector, one in-order traversal that we are going to put in our unordered set. And then after that, we are simply going to apply a for loop on the one which we haven't put in the set. And then we are simply going to find if the remaining number is available in the set or not. If it is, simply increment the value of count. If it is not, then simply move forward. And at a final sort, we are going to get our answer. So as now I have discussed with you like how the approach is going to work and how we are going to get the answer, let's just now move on to solve this problem. So as you can see, first of all here, what we are doing is we have taken two vectors. These are going to be used to show the in-order traversal. Then here is the in-order traversal code. So we are simply going to call for in-order traversal first of all for root 1. Then we are going to call for the root 2. That is the 2 tree node. After getting the in-order traversal, the next thing I am doing here is I am pushing the first vector in our set. So after pushing the first vector in our set, I am going to get some in the set. Okay. then I am going to do the traversal over the set which over the vector which I have not put in the set, and then the remaining element, which will be this one, we are just going to find that whether it is available in the set or not. As in this case it is not, we are simply going to move forward. If it is available, then we are going to simply increment the value of count and at the end return count as an answer. So this is the approach that we are going to apply. Now let's just submit this out, and as you can see, it is working pretty well. So yeah guys, with that, today we have solved both GFG's Leetcode and PODT of GFG and Leetcode. We hope that you will be able to understand that how these codes are going to work. With that, over to you, Shivam.
So yeah guys, thanks for joining with us. We will catch you up again